Why do atoms bond? Why does sodium suddenly become stable after meeting chlorine? And why are ionic compounds so hard, strong, and high melting? Welcome back to Rhythm of Words, where chemistry becomes simple, exciting, and unforgettable. Today, we are diving into one of the most important chapters of chemistry, chemical bonding. And trust me, once you understand this chapter, half of inorganic chemistry starts feeling easy. So grab your notebook, focus your mind, and let's unlock the chemistry behind attraction between atoms. Chemical bond is the force of attraction that holds atoms or ions together. But here's the interesting part. Atoms are actually selfish for stability. They want to become stable like noble gases, and to achieve that stable electronic configuration, they form bonds. That is the whole game of chemical bonding. There are mainly four important types of bonds. Number one, ionic bond, formed by transfer of electrons. Number two, covalent bond, formed by sharing of electrons. Number three, coordinate bond. One atom donates both shared electrons. Number 4, metallic bond. Positive metal ions surrounded by sea of electrons. But in today's video, our superstar is ionic bonding. Ionic bond is formed by the complete transfer of electrons from one atom to another. Usually, metals lose electrons, form cations, non-metal gain electrons, form anions. And then opposite charges attract each other strongly, just like magnets. Magnesium loses 2 electrons. Oxygen gains 2 electrons. Now both ions attract each other. Boom! An ionic compound is formed. This attraction between oppositely charged ions is called an ionic bond. And remember, ionic bonds are strong, non directional, and electrostatic in nature. Now, the big question: what conditions help ionic bond formation? There are mainly three important factors. Number one, low ionization energy. The atom forming cation should lose electron easily. Less ionization energy means easier electron removal. Metals like sodium and potassium form ionic bonds very easily because they can lose electrons quickly. Number 2. High electron affinity. The atom forming anion should love gaining electrons. Higher electron affinity means more tendency to accept electrons. That's why halogens like chlorine are excellent at forming ionic compounds. Number 3. High electronegativity difference. Greater the electronegativity difference between atoms, greater the electron transfer, and stronger the ionic character. That's why NaCl is ionic but HCl is mostly covalent. Simple. Now comes the king concept, lattice energy. This is where students usually panic, but not today. What is lattice energy? Lattice energy is the energy released when 1 mole of ionic crystal is formed from gaseous ions. In simple words, when positive and negative ions come close and form a crystal lattice, huge energy gets released. That released energy is called lattice energy. And this energy tells us how strong the ionic compound is. Higher lattice energy means stronger ionic bond, more stable compound. Factors affecting lattice energy. Two major factors control lattice energy, and these are super important for exams. Number 1, ionic charge. Higher the ionic charge, higher the electrostatic attraction, higher the lattice energy. Remember this trend. Because cation charge increases from +1 to +3, more charge, strong attraction, greater lattice energy. Number 2, ionic size. Smaller ions come closer together. Closer ions attract more strongly. So, smaller ionic size means higher lattice energy. Look at this trend. As cation size increases, lattice energy decreases because attraction becomes weaker. Now think logically. If ions attract each other strongly, will they separate easily? No. More energy is needed to break the lattice. Therefore, higher lattice energy, higher melting point. Higher lattice energy, higher boiling point. That's why ionic compounds are usually hard solids with very high melting points. Higher lattice energy means ions are held more tightly, so the compound becomes more stable. Simple relation. Higher lattice energy, more stable ionic solid. Relationship with solubility. Now, this part is very interesting. For an ionic compound to dissolve in water, water molecules must pull ions away from the lattice. If lattice energy is too high, water struggles to separate the ions. So, generally, lower lattice energy, more soluble. Very high lattice energy, less soluble. Because the ions are locked too strongly inside the crystal. Importance of lattice energy. Why do chemists care so much about lattice energy? Because it helps us predict stability of ionic compounds, melting and boiling points, solubility, strength of ionic bonding. So lattice energy is basically the power level of an ionic solid. What is lattice enthalpy? Students often confuse lattice energy and lattice enthalpy. Here's the easy understanding. Lattice enthalpy. Energy required to completely separate 1 mole of ionic solid into gaseous ions. Example, this process requires energy. So lattice enthalpy is generally positive, while lattice energy is energy released during formation. One is formation, one is separation. Opposite processes. Now let's enter the most scoring concept of today's video, the Born-Haber cycle. This cycle helps us calculate lattice energy indirectly using Hess's law because lattice energy cannot be measured directly. Formation of ionic compound happens in multiple steps. For NaCl, step 1 sublimation, step 2 ionization, step 3 bond dissociation, step 4 electron affinity, step 5 lattice formation. And this final step releases lattice energy. Using all these energies together, we calculate lattice energy through Hess's law. And trust me, once you master Born-Haber cycle, numericals become super easy. So today we learned types of bonding, ionic bonding, factors favoring ionic bond formation, lattice energy and lattice enthalpy, relation with size, charge, melting point, stability and solubility, importance of lattice energy, Born-Haber cycle. This chapter is the foundation of inorganic chemistry. Master these ones and the upcoming chapters become much smoother. If this video helped you understand chemistry in a smarter and easier way, then don't forget to like, share, subscribe to Rhythm of Words, and remember, chemistry is not about memorizing. It's about understanding the beautiful logic hidden inside atoms. See you in the next video.